Alright, so we're going to go over the exponent rules. This should be somewhat of a review, seeing that you had this on your summer packet test. Then we went over exponentials, and we used these type of rules in some capacity before. So I'm hoping that this isn't too crazy for you guys, but of course, as always, if you have questions, please let me know. So if we take a look, I'll do problems like ones we didn't do in class, because you have those written down already. But if I do a problem like this one and this one, this is the same thing as just saying we're multiplying. So negative 2 times negative 8 is 16. M and m to the fifth, if we're multiplying m and m to the fifth, that's the same thing as adding their exponents. So it's m to the sixth. Remember, there's that imaginary little 1 that we don't write, but we know it's implied. It's saying there's one m. For this problem, we do the same thing. We have negative 10 and 5, which becomes negative 50. X and x squared is x to the third. We added the exponents, and y to the third, and y is y to the fourth. So all we're doing is taking the coefficients, multiplying them together, taking the like bases, and adding their exponents. So if we take a look at something like this one down here, we do 8 times 7, which is 56. A squared, a to the third, a, and a to the third. You got to put them all together. This kind of looks like a b, so let me make it look like a 6. A squared, a to the third is a to the fifth, a to the sixth, a to the ninth. And then b, and b is b squared. So that's the same process you would do for any type of problem like this. So if we look at something like the number 1 on this problem, this is not saying 6 times 3. This is saying 6 raised to the third power. So this is the same as 6 to the third power, because if we're looking at this and this, you know we're going to multiply those two numbers together. However, this is the same thing as saying x to the fourth to the third power. So this is the same thing as saying 6 to the first to the third power. So we multiply those exponents, which just gives me 6 to the third. So we have to memorize that this is the same thing as saying 6 to the third power, which is 216. Then we have x to the 12th, y to the third, because we multiplied those exponents. Whenever it's raised to the power, or we have the parentheses, it's on the outside, we are going to multiply them together. So now let's combine all of this knowledge. So if I look at this problem down here, we are first going to start off, all right, yeah, I did that. The other one in class. Yeah, so we're going to do this one. We're going to first start off by doing the inside. A lot of us in class said, whoa, we can distribute the fourth power in. 100% correct. That is fine to do as well. I personally like to do the inside first. I like to follow PEMDAS, where it says parentheses first. So I do inside the parentheses, but the other way will give us the same answer. So if I do inside the parentheses, I do 2 times 2 times 3. So 4 times 3 is 12. X to the fourth, there's no other x's, so I'm going to leave it as x to the fourth. And then y squared and y to the third, I add, gives me y to the fifth. And then we're doing it to the fourth power. So once again, it's 12 to the fourth, which I put that in my calculator, and I get 20,736, which I know we all knew that on the top of our heads. And then we have 4 times 4, which is 16. 5 times 4, which is 20. And that would be our final answer. If I had something like this, I would do x. I would do the parentheses, exponents things first. I do x to the 12th, y to the 20th, times x to the 7th, y to the 4th. And then I'd be combining x12, x7 is x19, y20, y4 is y24. So I was just showing you a little difference of sometimes you're going to have to use that power rule and then the product rule, not vice versa. So let's take a look at things like these. We saw in class, I'm just going to relook at this one again because sometimes we get a little confused. Now, if we're doing 16 divided by 6, that's not going to be one of our whole numbers, one of our integers. So we just had to divide something out of both. So 16 divided by 2 is 8. 6 divided by 2 is 3. So we took out a 2 from each. Then we subtract the exponents. 4 and 2 is 2. 20 and 10, subtract them, we get 10. So if I look at something like this, if I did W2 and W1, I get W. 10 minus 8 is 2. 7 minus 3, so Y is a 4. And 9 minus 2 is 7. So I do exactly like that. If we looked at the problem below, A squared and A gives me an A, because 2 minus 1 is 1. And we just leave the rest the same because there's nothing else we can do. So let's look at one like this in the second one. We need to simplify our numerator and our denominator, then continue. So if I simplify my numerator, I'm doing 5 times 2, which is 10. X to the negative fourth and x to the third gives me x to the negative first. And then we have our lone y. In our denominator, we have 3 squared, which is 9. X to the fourth, y to the negative sixth. Once again, we're not done though. We need to subtract our exponents of our variables. So 10 divided by 9 is going to stay 10 divided by 9. We can't simplify it. Negative 1 minus 4 is negative 5. 1 minus a negative 6 is positive 7. So then we're like, wait, we have a negative exponent. Recall, we cannot have a negative exponent. So we have to bring it down to the denominator and make it positive. So we'll have 10y to the 7th over 9x to the 5th. We only bring down the term that's negative. We do not bring everything down with it, just the negative one, and make it positive. So what happens if there's nothing left in the numerator? So, for example, if we have something like this, this is a negative exponent. So we're going to bring everything down to the denominator, and we're going to have 2u to the fourth, all to the third power, times 5u to the sixth in the denominator, but there's nothing left in the numerator, right? That's when we throw in that one, which we saw with our exponentials when we were trying to simplify something that was like 0.73 to the third power. T minus 3 power. So let me write that down. I'm going to try a new one. If I had 0.36 to the t minus 3, remember we brought this down to the denominator, brought it positive. So we had 0.36 to the t over 0.36 to the third. And when we put this in our calculator, we did 1 over it. So anytime we have something like this, we're always going to leave, if everything is put into the denominator, we're going to leave it with a 1 in the numerator. So if I simplify this, 2 to the third is 2 times 2, which is 4, times 2 is 8. U to the 12th times V, 5. I don't know why I said V. U to the 6th. So then we do 8 times 5, which is 40. 12 and 6 is 18. In the denominator, so it's 1 over 40 U to the 18th. So we can't forget to put it into the denominator. So we saw that in class today, anything to the 0 power is 1. So this becomes 1. This is 1, which I like to just cross out because anything times 1 is itself. Over here, this would go away, and we would just keep on going. We're going to see things like this when we get into our polynomials. So I'm just going to skip all of this for now. It'll become more easy, I'll say. I don't want to say or, that's not a real word. More easy as we progress Wednesday and Thursday. So we went over what's the area formula of a square, which is length times width, and the volume formula of a cube is length times width times height. So we did that problem. Let's look at some here. So if I'm doing a cube, you guys told me that means I'm multiplying whatever the side length is by itself 3 times, or I'm raising it to the third power. So what I have to do first is if I have a problem like this one here, I have to do the inside. So I'm going to do 2 times 2, which is 4, x to the 7th y. But I still have that squared there. So I have to do 4 squared, which is 16. And then I need to multiply the exponents, so x to the 14th, y squared. So that's my new side length. I didn't do anything really to solve this problem yet. I just simplified my side length to make my life easier. So once I have this, I know that this is a cube, so it means I'm going to cube it, which makes sense, right? If it's a cube, we're going to cube it. But like you saw in class, you could also expand this and do 16x to the 14th y squared times itself, then times itself again, and you'll get the same answer. So if I do this way, I do 16 to the third, which becomes 4,096. 14 times 3 is 42. And y to the sixth, and that would become my final answer. Finally, we saw a problem like this in class, so I'm just going to go through it real quick so you will have a problem like this on your homework. So if I'm finding the perimeter, that means I'm adding all the side lengths together. So 10a squared b plus 4a squared b plus 3ab. And we can combine our like terms. So like I showed you in class, if we have a 5x plus a 3x, we get an 8x. But if we have a 5x plus a 3y, we cannot combine them. It just stays as is because we need to be having like terms. So if we look down here, this has 2a's, this has 1b. This has 2a's, this has 1b. So because they have the same terms, we're going to combine them and get 14a squared b. And this is not the same, so we're going to keep it as is for our perimeter. For my area, we have to recall that it's 1/2 base times height for a right triangle. So we're going to have 1/2 my base, which is 3ab. My height is 4a squared b. So 1/2 times 3 times 4 is 6. A and a squared is a to the third. B and b is b squared from our rules. And that would be my final answer. So I do have these more challenging problems. I'm going to make our homework a little bit more easier because I don't think that's necessary, but you will be doing some of these, so I will let you know which ones and just email me if you have any questions. Have a good day.